Hi, welcome. Good morning, folks, and thanks for attending. My name's Bob Flynn. I'm an instructor here at Palo Alto Networks, and we do a series of different webinars dealing with Prisma Access. This one is going to be about IoT security, the Internet of Things, as well as DLP to control access to sensitive information, data leakage prevention. If you're not familiar with Prisma Access, it is part of our SASE solution, which is designed to protect remote users that are not behind your traditional data center firewall, whether they might be in a branch office or mobile users sitting at home, like many of us are during the pandemic, or even things such as a secure web gateway, an explicit proxy for users that may do that. Now, a couple of the add-ons that are interesting and really beneficial for folks are IoT security and DLP protection. So we're going to talk about those today. We're going to talk a little bit about the need for IoT security. Then we're going to talk about how it works and the different pieces and parts, and how IoT security can integrate. It integrates with our firewalls, it integrates with Prisma Access, it integrates with many components of our platform here at Palo Alto Networks. As we go along, if you have any questions or comments or anything like that, there is a QA section, Q&A section, and we'd be happy to answer your questions as we go along or after the presentation is over. But please feel free to use that. So let's talk a little bit about the need for IoT security. You read about stuff all the time these days about internet connected devices, the Internet of Things that don't have users on them and aren't managed and things like that are causing issues. Years ago, there was a denial of service attack against one of the top tier DNS providers for the internet, brought down like a third of the internet around the world. And it was all a bunch of Nest thermostats. Whenever you have something that's connected to the internet, like an internet enabled thermostat or a doorbell or refrigerator, or if we're talking about the security cameras, that information is not being stored locally. And if you're talking about a business or an enterprise where traditionally information was stored in a data center on servers, well, that's no longer the case. And if you think about all of the different IoT and internet enabled things that might be on a campus or in a hospital or any sort of business, it's a lot. Security cameras, point of sale devices, like in the dining room even. You've got things such as badge readers that connect to the internet to let people in and out of places. You've got monitors, you've got thermostats, you've got central HVAC controls and all of those sort of things that are all internet connected and don't follow the traditional model of client server connections. So you read about all these bad things happening, hackers, people stealing information, IoT devices launching denial of service attacks and things like that. And you realize there is a need to protect these things. Well, current solutions don't really do much for you there. Finding IoT devices in a network can be tricky, and usually means there's going to be some need to re-architect networks in order to do that. There's no real built-in protection in most security products for protection of IoT devices, unless it might be signature based. But if you don't find all the IoT devices and you don't see the traffic, how do you protect them? So there's a lot of things that you got to think about that are hurdles in the traditional or current solutions to protect IoT. What we've decided, or what we do here at Palo Alto Networks, is we sort of use a new methodology to secure the Internet of Things and IoT devices. The idea is, first of all, you got to understand what you got. When we did a quick little, well, I shouldn't say quick little test, we use IoT security at Palo Alto Networks on our campus. And we found out on our campus, to my surprise, we had something like 8,000 IoT devices on our campus. I would have thought hundreds, over 8,000. So in a hospital or something like that, you can just imagine all of the IV drip machines that are connected to the internet, all the X-ray machines, all of that stuff, with all kinds of sensitive information on there. And also, when we're talking about healthcare, if an IV drip machine got hacked or misfired or was misused, that could be a life or death situation. So the idea is you got to get visibility into what's going on in your campus or at your enterprise or what have you. So you need to start with comprehensive device visibility, not just some sort of devices. You got to be able to understand exactly what you have. And the next thing is you got to be able to assess the risk. So different devices are going to pose different sets of risks. A security camera versus a IV drip machine versus a point of sale device that sees credit card information and stuff like that. They're all going to have different risks and different levels of risk involved in them. So you have to understand that not every device poses the same type of risk or amount of risk. And so you need to assess what that risk is on these different devices. Third thing is, based upon those assessments of risks, we need some way to prioritize and reduce the attack surface and the risk. Well, the best way to do that is in an automated fashion. So we can prioritize and automate this risk reduction and these policies. It becomes very difficult to do this manually. And if you don't satisfy the first two parts, understanding what assets you have and what the risk levels are, it's really hard to come up with a comprehensive solution for this. The fourth thing is we want to add and prevent known threats. Known threats can use things like security policy rules to allow and deny different behaviors, threat protection signatures and things like that. But the other thing is new threats. New and previously unknown threats need to be addressed also. And we have the ability to do that here at Palo Alto Networks with things such as wildfire, machine learning, artificial intelligence, things like that, to be able to address both known and unknown threats. So the point is here, you need a comprehensive methodology to do this. It needs to be scalable, and it needs to be easily accomplished, and it needs to be done without a whole lot of capital and operational expenses and hiring a whole new team to do this sort of stuff. So we'll kind of look at these things and how we solve this as we go along here. So if we look at these 5 different things again, we'll start with number 1 there, understanding IoT assets. We have the ability to discover any sort of IoT or IT device in your network. Most of them within about 48 hours, about 90%. It depends on how often they connect. Things like security cameras that are almost always on, yeah, we'll find those immediately. If we have something that maybe checks in on a weekly basis, we have to wait to see that check in before we see it. But we continuously monitor and make sure we don't miss devices, new devices connecting, devices that rarely connect, devices that are always on, that sort of thing. And we detect new or never seen devices based on about 50 different attributes. The idea is we want to be able to classify these devices, determine what they are and who the manufacturer is, what is normal behavior, what is abnormal behavior. And so we use real-time monitoring and risk scoring to be able to look and assess the risks of all these devices. We get information about vendor advisories, vulnerability information from all kinds of different feeds. We track risks for compliance and look back or retrospective analysis. We have the ability to customize risk levels within frameworks, with the idea that once we can assess these risks, then we can apply risk reduction policies. So this consistent profiling of device activities is going to be converted into this risk-based policy recommendations. These are recommendations that are going to be made by our IoT protection functionality and can be integrated with your next generation firewalls, Prisma Access components like our remote network SPNs, other pieces and parts of our platform. But the idea is that these are not going to be policies that one has to build and come up with themselves, but they're going to be recommendations that are automatically going to be sent, and those can be implemented across your infrastructure, across our platform. Kind of the way we do this is the different devices like next generation firewalls are what we're talking about, Prisma Access with our security processing nodes. We get information from these devices as the traffic is passing through our devices. So data in motion. And we're able to log this information and send it up to our IoT cloud-based service that then analyzes this information. Again, we can use machine learning on our devices. We can use machine learning up in the cloud, artificial intelligence, information that we've gathered from across our customer base around the world to understand and sort of crowdsource this information for IoT protections. Use this information to do things like block IoT malware and spyware and exploits and things like this for known threats. Send those protections, those signatures, as well as policy recommendations down to devices to be implemented to protect. And then for unknown threats, we can do ongoing monitoring. I use identity information. We have the ability to look for deviations and behavior changes in behavior. We have the ability to block unknown file-based and web-based threats. We have the ability to integrate with XSOAR and all kinds of other integrations that we do in order to continue to monitor and identify and give you actionable recommendations, not just let you know, but give you information on how to stop this sort of stuff for never seen before threats that you might see in your network. We look at the components, the pieces and the parts here. of IoT security. Well, we'll sort of delve into this for a moment. First of all, devices are brought up on a network, IoT devices, cameras or robots or whatever the case may be. Well, these devices are going to generate a unique identifiable pattern of network behavior. They're going to register, they're going to get IP addresses, they're going to use DHCP and things like that. And we see this information. This is where we can start building and collecting data and understanding what these devices are. This information is going to be collected by Prisma Access, security processing nodes, next generation firewalls, whether virtual or physical, other different signal collectors, other different security devices we see on the network. We collect this data, this metadata from the network traffic in these IoT devices, and we use this to generate what we call EALs, or enhanced application logs. This information gets forwarded up to Cortex Data Lake. Cortex Data Lake is where we store, it's our cloud-based storage solution for logs. And this is where we have our log repository up in the cloud. Our IoT Security Cloud reads the metadata from those EALs, those enhanced application logs. It uses machine learning and artificial intelligence to look at the behaviors and identify changes in behavior, understand what's normal for a particular type of device and what's abnormal, looking at source and destination information, be able to maintain and update that information and baseline and monitor each device's normal activity in your environment. Then, when we see actionable recommendations, we can either notify admins with emails or SMS notifications or whatever, or send that information down to devices with the recommendations to be able to implement with the click of a button, saying these are security policy rules, these are implementations, these are threat protections, these are things we think you should do. Here's a list of them, click here, we'll implement them for you. Or as I said, it can be parsed through an administrator who wants to choose what they do and don't want to do. This can be pushed through Panorama, our centralized management tool, to implement them both on firewalls and Prisma Access centrally from one pane of glass, or sent individually to firewalls that are not managed through Prisma Access, or through the cloud management tool of Prisma Access. So I guess the question now is, if we kind of understand at a high level the components, we see devices on the network, we use our devices to be able to signal and get this metadata with these enhanced application logs, send it up to our IoT Security Cloud, parses this information, comes up with recommendations to secure these devices and sends them to you. Kind of understand that. Maybe the next question is, how is this information found and digested? So we have a few steps here that we do. Basically, when we see these logs, the enhanced application logs, along with traffic logs and app ID information and threat log information and things like that, all the normal logging we do along with the enhanced application logs, we start to get information, MAC addresses, IP addresses, DNS information, thread information, application headers, payloads, different things from different types of logs here. This helps us, this is that metadata that we're going to use to assign a device to a category, to categorize a device. We first want to identify the category which the IoT device belongs to. Is this a security camera? Is this an IV drip machine? Is this a thermostat? What is this? The next, what we do is our IoT Security Cloud starts to construct a profile of the device. Now we kind of know what it is. We know generally what it is. We can figure out the manufacturer and all that sort of stuff. But we want to create a profile that includes things like the vendor, the make, and the model. Any sort of known security vulnerabilities and things like that for these devices, as well as any sort of software updates that might be recommended, things like that. But also beginning to look at and analyze information and behavior over time to baseline that information and understand when or if things are acting abnormally, which then gives us the ability to do our threat detection and device information detection and give you those recommendations. So it's sort of a 3-tier process that we go through to get to the point that we can give you those recommendations. Now, this metadata, this information that's contained within these enhanced application logs, looks at multiple different parameters, hundreds of them, a couple hundred of them, to match different traffic patterns and device types and things like that. Some of the things it does is looks at option 55 parameters for DHCP. We'll take a look at some of those. User agent IDs, browser types and things like that. Protocols that are being used, protocol headers, information such as that. If we were going to look at a packet capture of a IoT device reaching out to a DHCP server to register and get an IP address, one of the things you will see is the option 55 parameters. That's what we talked about on the last screen. So what are those? Well, you get vendor specific information there. What is this thing? What's it called? What is it? Domains that it may be connecting to or use, domain searches it does, TCP IP node types and servers and port numbers and things like that could all be useful to help understand what this device is. And then how do we get this up and running? So when it comes to Prisma Access, this is an add-on product. First thing you got to do is enable enhanced application logging. And this is going to be under the logging settings. Then, in order to receive these logs, we need to see traffic generated by these DHCP requests or probes or the devices online. So we need security policy rules to capture both DHCP and ping information and stuff like that, as well as the traffic information from these IoT devices. But remember, you need security policy rules with allow and deny actions for things to show up in your traffic logs. Also, especially with Prisma Access, make sure you turn on the logging for your default rules. Because if you don't have explicit rules, it's going to fall to your default rules. Next thing is you got to forward these logs to Cortex Data Lake. So you do need a log forwarding profile in order to do that. And in the log forwarding profile, you need to make sure you enable the enhanced application logging to forward that to Prisma Access. I'm sorry, Cortex Data Lake for Prisma Access. Let me be more specific. And since Prisma Access runs PAN-OS, our next generation firewalls run PAN-OS. Basically, they integrate and get their information the same way through the device ID fields that are in PAN-OS, which also gives us the ability to have things like a device dictionary, which is an XML file that the IoT Security Cloud generates and makes available that can be imported. So basically, it can give you an inventory and a dictionary of all your devices, which allows you to do things like group them together by device or IP ranges or things like that. And also have policy rule recommendations based upon this device dictionary that's available to you. This is going to help you come up with to implement these rule recommendations easily, and by grouping things together and being able to have simplified sets of rules without having to have complex sets of rules, multiple rules for each single device. If we got a bunch of devices that are the same, we can group them together and create a single rule for that group. And it's that device dictionary that's sort of the linchpin to being able to simplify this process. So as I said, this dictionary is a XML file that's available for Prisma Access or firewalls, any PAN-OS device, to import it. And it gives you a whole list of device attributes, device names, device types, operating system types, and things like that. So as an example, this device dictionary may say, well, here's a group of your internet connected thermostats. And you got 3 different groups from 3 different vendors. And within, say, the group 1, which was from vendor A for my thermostats, they're running Raspberry Pi or some flavor of Linux version, blah, blah, blah. Well, then you got some other ones that are running a different version. Well, then you got another group from a different vendor that's running a different operating system. So these are the things you're going to see in the device dictionary. You're going to be able to see what the devices are, sort of how they're classified into what the device is, who the manufacturers are, operating systems that are running, IP ranges, things like that, model numbers, all of those sort of things, to be able to classify and group together these devices very simply. So you'll be able to now map devices based not just on IP addresses, but MAC addresses, host names, device types, device categories, vendors, models, operating systems, as well as different risk levels and scores. I'm not going to read the entire list for you, but you get the idea. And the whole drive here is to reduce the complexity, reduce the manual overhead, and be able to efficiently give you this information. And that's what these policy rule recommendations we keep talking about are. This is the easy button to be able to do this. These recommendations can be sent to devices. They can be administered by admins and imported to the firewalls for enforcement. You may have a list and you may not agree with every single thing on the list. You can add the pieces and parts you want. You can go back retroactively and change or disable these recommendations. You can go back and retroactively enforce recommendations from a long time ago that you just now decided should be done. So it's very very flexible to be able to do this sort of stuff. Now, the other big topic we're going to talk about is DLP. The idea, again, it's traditional DLP, has a lot of holes in it. There's usually a lot of additional devices. There's usually a lot of additional overhead and expertise required to implement this. And the other thing we're running into these days is, well, data's not stored on site like it used to be. You know, back in the day, everything was stored in a data center on a server. You know, you had your local email server, you had servers with databases full of information and application servers and all that sort of stuff. And it was all internal. It was protected at the edge by a security stack, like with firewalls and IPS and stuff like that. And your job is basically to keep the bad guys from getting in. Well, now the same sensitive information, so security information, your payroll information, people's healthcare information, social security numbers, all that sort of stuff is no longer inside a data center. Now it's out in the cloud. It's all over the place. It's dispersed all over the place. Sanctioned and unsanctioned areas, and sanctioned, unsanctioned applications, public cloud, all that sort of stuff. People sharing information, maybe information they should or shouldn't, having bad security settings for all of that. These are all the things that cause this whole idea of protecting your data difficult. This data can be accessed from anywhere directly. Managed and unmanaged devices. You know, you can read your email from your corporate device. You can probably reach it from your phone too. And is your phone well protected? I don't know. Maybe it is, maybe it's not. Are you accessing sensitive information? If you are you storing it locally? Are you storing it up in sanctioned SaaS applications? Are you storing it in your own private drives? There's a lot of things you got to think about here. So data breaches, of course, are on the rise. They're happening all the time. You can't pick up the newspaper without reading it. And none of your customers want to be part of this. So they need some way to protect their sensitive data. There's all kinds of regulatory and compliance rules about this. GDPR in Europe, PCI, payment card information protections, HIPAA laws here in the United States, Sarbanes-Oxley, different financial data accuracy and data protection information. So there's lots of different regulatory things that have to be followed. Worrying about personal identifiable information, intellectual property, things like that. And you got to worry about not only stuff from the outside, but stuff from the inside. Whether it's malicious actors or well-meaning people that just have shared information outside of the organization or with people inside the organization that they probably shouldn't have, without even realizing it. So you got to have a comprehensive solution. First thing you got to do is understand where your sensitive data is. Where is it being stored? How is it being used? where is it being uploaded to? What's it being used for? Who's copying it? Who's using it? Are these sanctioned use cases? Are these following internal and governmental compliance rules? And then you got to figure out how to protect it. But, until you know where it is and who's using it and how it's being used, is kind of hard to figure out a good way to protect that data. Traditionally, DLP solutions, legacy ones, are very complex, usually multiple moving parts with multiple different vendors, usually integration of lots of different things, and the need for being able to do PCAPs and ICAPs and things like this to get this information, reliance between devices that find and obscure maybe sensitive information, also relying on network devices to decrypt it, to be able to see it and things like that. So it also becomes really expensive. Lots of different products and licenses and lots of infrastructure, usually a dedicated team to run this sort of stuff and figure it out. And it's also resource intensive on your networking and security devices. The more you have to decrypt, the more you have to look at, the higher the resource utilization on things like load balancers and firewalls and security devices and things like that. It's also resource intensive for people. When you're dealing with thousands and thousands and thousands of alerts every day of all flavors, dealing with network alarms, DLP information, IoT information, all that sort of stuff. Somebody's got to classically, compile, read through all these alerts, and research them, understand them, and action upon them. Automation is going to fix a lot of that. Oops. I think I lost my screen sharing. 1 second, folks. Sorry about that. So as I said, lots of challenges we have to think about here. And automation is going to help a lot of those. But what we can do with ours is, first of all, it's a centralized solution. So we're not talking about a bunch of infrastructure all over the place. It leverages what's already in your network, what's already in your enterprise. We can automatically use automation to discover, monitor, and protect sensitive data. We can figure out where it's at. We can discover it in the network, across the cloud, on endpoints, data in motion, data at rest. We have the ability to monitor and understand how the data is being used and make recommendations to protect it and stop sensitive data leakage, enforcing different protection policies, and helping educate employees to understand the proper ways to categorize and use information, and what is compliant, what's not compliant. All of this is going to be helpful. So this all begins with our DLP cloud service, our data leakage protection. And devices inside your enterprise, such as Prisma Access, and other devices like firewalls and SaaS Security Solutions and Prisma Cloud, and in the future, other pieces, also our endpoint protections and things like this, can all signal and send information to one place, one repository, the cloud-based DLP's engine. We can come up with recommendations and protections that can then be sent to all these different devices. We can, of course, leverage all those things we always do in the cloud with machine learning and artificial intelligence and things like this. We have remediation workflows and analytics and configuration recommendations and all of those sort of things that we can give to a person that we can leverage up in the cloud. And this means it scales. We can make improvements without you having to upgrade any of your on-premise equipment or things like that. And that's true of any of our cloud-based solutions. Now, some things, such as firewalls and Prisma Access, are going to be looking at data in motion. In other words, we see information being shared, we see it come across the device. That's where we're going to see it. Other ones, other pieces of our platform, such as Prisma SaaS and Prisma Cloud, are looking at data at rest. So in other words, with networking devices, next generation firewalls, our VM firewalls, Prisma Access, where traffic is coming through us and we're inspecting that traffic. As the traffic comes through us, we see it. Other pieces of the platform can also look at data at rest, data sitting in files on Office 365, sitting in folders in Box and looking at information in Slack and all those sort of things in order to protect that information even before it tries to be transferred on the network. So we kind of use both of these ideas. Implementing this in Prisma Access, I got some examples here through Panorama. Simply under Panorama and our cloud services configuration, where you'd be doing all your work with Prisma Access and stuff like that already. We have the ability to activate DLP, or we can request a trial. You can kind of play with it and see how you like it. If there's any sort of file upload and download protections and data filtering that you've already configured, Enterprise DLP is a replacement for that. So it's going to turn that stuff off and enable the DLP provisioning. Once we do that, then we can set that information up to the DLP service. There's nothing else you have to deploy. There's nothing else you have to set up. There's no additional policy rules or anything like that. You don't need any proxy or ICAP devices or anything like that. You configure it a single time on the devices, Prisma Access, your next generation firewalls up in Prisma SaaS or whatever. You implement it, you set it. The DLP service begins understanding this information, uses predefined data classifiers to classify traffic using machine learning and regexes and pattern matches and all kinds of stuff like that. We have more than 850, and this is always expanding, different predefined data patterns to look for sensitive information. Everything from looking for credit card numbers, social security numbers, stuff like that, to more complex and regional type things also. We can give you confidence levels as to how we feel about the results of this, and be able to give you the ability to build your own, look at data at rest and data in motion, to be able to then understand the context. What is this content? Is it credit card numbers, social security numbers, intellectual property, confidential information, not for distribution? Give you context, the who, what, when, where, whens. Where is this information? What is this information? Who's got this information? How are they being used? Then within our responses, again, we can look at who we need to notify, whether we need to unshare or quarantine this information, prevent access to this information, who's the user or the group or the team that's doing this. Does this information need escalated? Things such as that for the responses. And the idea is to simplify and automate this process, so someone doesn't have to comb through the logs and do this everywhere, do this themselves. And the other big thing about DLP is it's available everywhere, not just Prisma Access, not just our firewalls, but with Prisma SaaS Security, Prisma Cloud. Prisma Cloud is designed to secure public cloud stuff. Our SaaS Security is to look at all the different SaaS applications and all the information stored up there outside of your perimeter and make sure that it's safe. And in addition to just making sure the information's safe and share levels are correct, now we can look at sensitive information with DLP and make sure that's safe also. There are different settings and different pieces and parts and limitations on these. When we're talking about Prisma Access, again, we have more than 850 predefined patterns. We have the ability to have 17 separate profiles, much more than say Prisma Cloud or some of the other devices. Since it's data in motion, right? We have the ability to block for uploads or just alert. We have a bunch of different app IDs, of course, all of our normal ones. There's 11 specific web ones that deal with DLP that are used exclusively for DLP. We'll have those too. We can look at all kinds of different, more than 20 different file types. Had the ability to leverage our machine learning and information about file properties. We had the ability to do snippets. So snippets are sort of like PCAPs, but they're more human readable information. The ability to replay and understand what's going on, see how information is being shared or being protected. So they're almost like capturing something on your iPhone and replaying it, but this is data. The ability to give you different confidence levels and the ability to use custom data patterns, which isn't available in all of our products, but basically the next generation firewalls and Prisma Access give you the full complement of all of our stuff. And that is an overview of IoT protection and DLP protection with Prisma Access. There have been some questions as we've been going along, and I think some have been answered in Q&A. I think there may be a couple of outstanding ones. I got just a couple of minutes here. Maybe we can take a quick look.